Hello grade 10 learners, have a nice day. Welcome back to my channel. For today's video, I'll be discussing to you how to find the roots and the factored form of polynomial equation using rational root theorem. Let's begin with understanding about rational root theorem. Let p of x is equal to a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus plus a sub 1x plus a sub 0. The possible rational roots are of the form p over q, where p is the set of all factors of a sub 0. By the way, a sub 0 is the constant term, constant, while q is the set of all factors of a sub n, and a sub n is the leading coefficient here. The leading coefficient, and this one is the constant term. Remember that it should be arranged in standard form, starting a term with the highest degree up to the constant term. So descending order. Now let's begin with an example. Find the rational roots of x cubed minus 6x squared plus 3x plus 10 is equal to 0. First, we have to determine the value of our p, or the constant term. So we have here 10. Next, determine the factors of 10. Talking about factors, it refers to numbers that when we're going to multiply together, it will give result to the given number. Just like 10, the factors of 10 are 1 and 10. So once you multiply 1 times 10 or negative 1 times negative 10, the answer is 10. You also have 2 times 5 or negative 2 times negative 5, you also have 10. So that's why we have here factors. So instead also of writing 1 and negative 1, we can also write it in this way, plus minus 1, to denote plus positive 1 and negative 1. Okay, so therefore, factors of 10 are positive, negative 1, plus minus 2 to denote positive and negative 2, and plus minus 5 and plus minus 10. Next, determine the value of our q. So in here, it is coming from the leading term, x cubed, and it's understood that the leading coefficient here is 1. So therefore, our q is 1. And of course, the factors of 1 are positive and negative 1. So 1 times 1 and negative 1 times negative 1 is positive 1. Next, we have to determine the possible roots. So we have p over q based on the rational root theorem. How are we going to determine our p over q? Of course, we're going to divide it 1 by 1. So 1 here, start, positive and negative 1 divided by plus minus 1, that is also equal to plus minus 1. Next, plus minus 2 divided by plus minus 1, that is equal to plus minus 2. Plus minus 5 divided by plus minus 1, that is equal to plus minus 5. And plus minus 10 divided by plus minus 1 is equal to plus minus 10. So these are our possible roots. So all in all, we have how many possible roots? Here we have 2, 4, 6, 8. So all in all, we have 8 possible roots. Next, we have to check these values for 0 in our given equation. Since we have the possible roots, we have to start with checking if which among the possible roots is a root of the given equation. So let's begin with 1. Where did we get 1? from the possible roots. So starting with 1. Okay? So we will be using synthetic division. So again, we have to write the coefficient. Okay, we have here 1, then negative 6, 3, and 10. And I believe that you have already mastered about synthetic division because I have made a video on synthetic division. To test whether 1 is a root or not, so we have here 1. Same, bring down 1. 1 times 1 is 1. Negative 6 plus 1 is negative 5. Negative 5 times 1 is negative 5. 3 plus negative 5 is negative 2. Negative 2 times 1 is negative 2. 10 plus negative 2 is equal to 8. Since we have here a remainder which is equal to 8, it means that 1 is not a root. Okay? 1 is not a root since our P of 1 is not equal to 0 because we have here a remainder. So next we'll proceed with the second test. We already through with positive 1. Now we will test negative 1. Test at negative 1. Same. You write the coefficients of x cubed minus 6 squared plus 3x plus 10. So we have it here already. Same process. Bring down first number 1 times negative 1. So we have negative 1. Negative 6 plus negative 1 is negative 7. Negative 7 times negative 1 is 7. 3 plus 7 is 10. 10 times negative 1 is negative 10. 10 plus negative 10 is 0. Since you have already 0 here, so it means that negative 1 is a root since the remainder is equal to 0. Now we have already a root. Next is we are going to find the depressed equation. We're going to find the depressed equation. We have to base it here in our quotient part. So in our previous lesson about synthetic division, the quotient part, so this is equal to x squared negative 7x plus 10, and just equate it with 0. This is what we call depressed equation. Now with the depressed equation that we have, since it's already quadratic equation, it is easy for us to solve for x. And in your grade 9, it has been discussed to you on how to find the roots of quadratic equation. So, factors of 10 that will give a sum of negative 7 are negative 2 and negative 5. So of course, factors of x squared are x and x. Factors of 10 are negative 2 and negative 5. But their sum is negative 7. Next, equate its factor with 0. So we have here x minus 2 is equal to 0. And the other one is x minus 5 is equal to 0. So for x, so negative 2 will be transposed to the right side. So it becomes positive 2. And the other one, negative 5, becomes positive 5. So we have now 3 roots already. So we can now conclude that the roots of x cubed minus 6 squared plus 3x plus 10 is equal to 0 are negative 1, this one. Next, the value of x, 2. And the last is 5. Now, since we are also tasked to find the factored form of x cubed minus 6 squared plus 3x plus 10 is equal to 0, we'll just connect this one. We already have the roots. So, it is quantity of x minus r sub 1 times quantity of x minus r sub 2 times quantity of x minus r sub 3, or times quantity of x minus r sub 4, and so on if you still have another roots. But this time we have up to 3 only, so we'll have x minus -1. So just substitute. Then here we have x minus 2. Then we have x minus 5. So simplify further. So we have negative times negative is positive. So finally we have x plus 1 times quantity of x minus 2 times quantity of x minus 5. So this is now the factored form of x cubed minus 6 squared plus 3x plus 10 equals 0. Now let's consider the second example. First, we have to check if it is already arranged in standard form. The terms are arranged in descending order. So since it's already in standard form, we have to determine the values of our p and q. So let's determine first the value of our p. So our p here is equal to 2, the constant term, and the factors of 2 are plus minus 1 and plus minus 2. Next, we have to determine also the value of our q. So this time our q is equal to 2 also. It is coming from the leading coefficient. So factors of 2 are same with positive and -1 plus minus 2. So the possible roots p over q, we have to divide. So 1 divided by 1, or plus minus 1 divided by plus minus 1, that is equal to plus minus 1. Then plus minus 1 divided by plus minus 2 is equal to plus minus 1/2. Then 2 divided by 1, that is equal to 2, or plus minus 2 divided by plus minus 1 is plus minus 2. And lastly, 2 divided by 2, so we already have 1 here, so no need to write it twice. Now let's have to test. Let's begin with positive 1. We will be using again synthetic division. Test at 1. So we have to copy the coefficient. So we have here 2, -3, -4, 3, and 2. And of course, here for our test number, which is equal to 1. First, bring down 2. 2 times 1 is 2. -3 plus 2 is -1. -1 times 1 is -1. -4 plus -1 is -5. -5 times 1 is -5. 3 plus -5 is -2. -2 times 1 is -2. 2 plus -2 is equal to 0. So our remainder here is equal to 0. So it means that 1 is a root of the given equation. Next, we have to determine the depressed equation. So our depressed equation is based on the quotient here. So we have 2x cubed. So why we have here 2x cubed? Remember that the degree of the given polynomial is 4. So to get the first depressed equation, the degree will be less than 1. So that's why we have here 3. So 2x cubed. Next we have -x squared. Then we have -5x and -2. And it is equated with 0. So since we have already the depressed equation, we can now determine the possible roots for this equation. So determine again the value of p. So we have here negative 2. And the factors of negative 2 are plus minus 1 and plus minus 2. Next, our q is 2, the leading coefficient. And of course, the factors of 2 are plus minus 1 and plus minus 2. Almost the same with the first factors. So therefore, possible roots are plus minus 1 half, and plus minus 2. Same with this. Okay. Now we have to test. We'll start with negative 1. So we will not test anymore 1 because 1 is already a root. So we'll start now with negative 1. So test at negative 1. So we have to write first the coefficient. So we have here 2. Then we have negative 1 coming from the coefficient of negative x squared. Then negative 5, negative 2. Okay, let's begin with the synthetic division. So bring down 2. 2 times negative 1 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 3 times negative 1 is 3. Negative 5 plus 3 is negative 2. Negative 2 times negative 1 is 2. Negative 2 plus 2 is equal to 0. So it means that negative 1 is a root since our remainder is equal to 0. Now we have to get the second depressed equation. So for our second depressed equation, we have to base it here. So we have now x squared as the highest degree for our second depressed equation. So we have 2x squared minus 3x minus 2. It is actually coming from here. 2x squared minus 3x minus 2 and equate it with 0. Why we have 2 as our exponent? Because in our first depressed equation, we have already here 3. So it follows that the next depressed equation will be less than 1 when it comes to its degree. Okay. If you have observed, we come up now with quadratic equation. Quadratic equation, so therefore we have to solve the value of x by using the different methods, but this time we're gonna make use of factoring. Okay, I'll be teaching you the shortest method of factoring quadratic equation where the value of a is greater than 1. So here our a is greater than 1 because we have here 2. Okay, first just copy this one. The literal coefficient of quadratic term x squared as well as the linear term. Okay, again copy the literal coefficient of the quadratic term and the linear term. So we have here x squared minus 3x. Next, you multiply the coefficient of the quadratic term, which is 2, multiply it by the constant term, which is negative 2. So 2 times negative 2 is negative 4. That's why we have here negative 4. Okay, equate it with 0. Now we have to factor out x squared minus 3x minus 4 by factoring. So factors of x squared are x, and factors of negative 4, that will give a sum of negative 3 or negative 4 and 1. So negative 4 times 1 is negative 4, but once we add, we have negative 4 plus 3, that is equal to negative 3. Next, we have to divide the constant term of its factor by 2. Why 2? Because 2 is the value of our coefficient. Okay, leading coefficient here. So we have to divide negative 4 by 2 as well as 1 by 2. Again, where did we get 2? Coming from the coefficient of the quadratic term. Okay, we also have here coefficient of the quadratic term 2. So whatever be the coefficient of the quadratic term, that will be the number that will be divided to the constant term in the factored form. Now let's simplify further. So we have x 4 divided by 2, that is 2. So we have x minus 2. And then the other one we have 1 plus 2. So what shall we do with this? Okay, we have to transfer 2 in front of the variable x. That's why we have here 2x. Why we have it in front of the variable x? Because we have to multiply this by 2. Okay, once you multiply this by 2, so this will become 2x, and 1/2 multiplied by 2, that's already 1. We can cancel out the common factors. So that's why we have 2x plus 1. And the other one is quantity of x minus 2. Next, equate its factor with 0. Then solve for x. So here, transpose, this will become positive 2. And 1, transpose to the right side, so it became negative 1. Then divide both sides by 2. So we have now x that is equal to negative 1/2. So therefore, the roots are 1 is coming from here. Next, negative 1. And the third one is the value of x, 2. And then the fourth one is negative 1/2. If we have observed, we have 4 roots because the degree of our equation is also 4. Okay, these are our roots. Okay, actually, you can copy the factored form for this because in the previous slide, we already have the factored form for this. Okay, so we have now to substitute. So x minus the first root, x minus the second root, negative 1, and x minus the third root, x minus the fourth root. Simplify. Finally, we have x minus 1, then quantity of x plus 1 times x minus 2 times quantity of 2x plus 1 is equal to 0. Again, what we have here 2x plus 1, it's because negative times negative is positive, and we have to multiply this by 2. So we have now 2x plus 1. So this is now the factored form of 2x to the power of 4 minus 3x cubed minus 4x squared plus 3x plus 2. Thank you so much for watching, guys, and if you have questions or clarifications regarding the video, just write it in the comment box. Kindly share to other students for them to learn or master the lesson. Please don't forget to subscribe to be updated for more math lesson videos and turn on the bell for notifications. Before I end, let me share to you one of the verses from the Bible. The fear of the Lord is the beginning of knowledge, but fools despise wisdom and instruction. Proverbs 1 verse 7. That's all for today, and God bless you all.